I don't know how you do I thought you were part of the counseling goal was to help the student.
Here we go. We got okay. Definitely. The assignment tonight is this packet. This one is outlined like the last one, and I was able to give you space to do the work here, so you don't need to worry about doing it on separate paper. Answers in the back again. Again, don't do this procedurally. Don't just blindly say, oh, I do this, then I do this, and then I get an answer. Like, make sure that you understand what's really happening. Okay? It's hard to, I don't know, until you take the first test, it's hard to get you to understand that they're going to give you all kinds of different problems, so you just have to make sure it's making sense. Okay, one thing you have to memorize is this basic idea. You do not need to copy all of this down, but you do need to memorize that if you have an exponential function that involves x, like say this one here, e to the 2x, and x is getting bigger and bigger and bigger and bigger, this is going to get bigger and bigger and bigger. It just grows, okay? The same is true for power functions. These are just examples. Again, you don't need to copy them down if you don't want to. Power functions also grow, as do natural log functions of this kind of type, just simple ln expressions. So they just get larger and larger and larger as x gets bigger. However, you have to memorize that exponentials grow the fastest, then power functions, then the log. There have been quite a few questions over the years on the AP test that will test your memory of that fact. So that's just, have to have that memorized. I added sine and cosine because there was a question one year where they expected you to remember that as x gets bigger and bigger, the sine function doesn't grow at all. It just moves around like between 1 and -1. So add this to your list of I must have memorized that exponentials grow fastest, then power, then natural logs. Questions about anything there? I added here that the natural log of x is undefined if x is equal to 0 or if x is negative, so you don't have to worry about negative values here. You might want to add this to your notes. Might is a teacher's code word for you. You probably should. If x is approaching negative infinity, something different happens. So if x is approaching negative infinity, e to a negative number, as that exponent gets more and more negative, this gets closer and closer to 0. It never equals 0, it just gets infinitesimally close to 0. You'll need that once in a while on the homework tonight. The power function will depend on the power. An odd power will get very, very negative, like a very large negative value. An even power would get a very positive large value. The positive and negative aren't always significant, but that's the difference between these two. As x approaches in negative infinity, this is going to get close to 0. This will get very, very negative. So you get a little bit different behavior in that case. It doesn't apply to this because the natural log of a negative number is undefined. So follow-up questions from anyone? Awesome. Okay, examples for the homework tonight. I was going to start with this one right here. So write down this right here, please.
So if it's negative, it's just mean that the exponential, they all get close to 0?
No, good question though. So if x is a number that's getting more and more negative, a function like e to the 2x or e to the x is going to get very close to 0. A power function will get either extremely negative or extremely positive. So again, put this example in your notes to help you with the homework tonight. Okay, I believe I had you write in your notes last time that when you see a limit problem where they're giving you a formula, so it's not a graph, your first thought should be, hey, let's see if it's a limit as x is approaching infinity. Which it is in this case. And if it is a limit as x approaches infinity, what you're going to do is you're going to compare terms that are I guess terms that add, terms that are being added. That statement's kind of redundant. The word term mathematically means two items that are being added. But I've had a lot of students forget that, so the risk of being redundant. We're taking two things or three things, if they're being added, we want to compare them. So if x is approaching infinity, we want to compare things that are being added. Do not try to compare things that are multiplied. So don't compare factors. At least not initially. Later we can, but not initially. Okay, so I look up here. The numerator is just 4n squared, so nothing is being added. These two things are being multiplied, but I don't compare things that are multiplying. That's what a factor is. So don't compare factors, items that are being multiplied.
What do you mean compare?
I'll show in a second. Good question. So what I mean by compare is I look at the denominator and I notice there are two items being added. There are two terms, n squared and the 10,000n. Here's the comparison that I'm referring to. As n gets bigger and bigger and bigger and bigger, both of these will get larger. But the squared term will grow so much bigger than the non-squared term that the best example I can give is think of having a scale. An elephant steps on the scale. Right? You read the weight of the elephant. If an ant happens to crawl onto the scale, you probably won't even notice. The same thing is happening here. When an ant is really big, these two things are going to add together, just like the elephant does add with the weight of the ant. But this one is so much larger, you don't even notice this. So it's negligible. So we can say that this limit's value is going to be exactly the same as this limit's value. Okay, caution. On the AP test, half of your points come from the written section. You have to use the equal sign. You can't just have a bunch of stuff that the grader can't tell how it connects. So you tell the grader. If you gave me this limit problem to solve, I figured out that this limit is exactly the same as this limit. So make sure you write the word limit. So you're declaring to the grader that you understand that these two limits are equivalent because of the fact that the n squared will dominate over the 10,000 n as n approaches infinity. Questions? We need to restate anything. Okay? After you've done this comparison that Josh asked about, next thing you do is you look to see if you can factor and divide. So this is already factored. I'm just going to split it up to make it easier to see. Questions? Again, don't just copy my procedure. Copy my logic. Make sure that you logically understand why I'm able to go from here to here and from here to here. That's what's crucial for this class. Okay? Let's see. Now it's easy. As n gets bigger and bigger and bigger, this becomes 1. This becomes 4. So basically, for this function, if you have an x-coordinate that's really big, the y-coordinate will be very close to 4. So we found the value of the limit. The limit's value is 4.
So how do we find 4?
So what we said was, if you could pick up a calculator and type in, say, 1,000,000, the calculator would give you a result that would be very close to 4. But you're not allowed to use your calculator. They expect you to use some of these kind of logical reasoning skills instead. So we said, well, I can't really plug in a number and do it in my head. It's too difficult. So I'm going to use this technique to make the problem easier to understand. So I went from trying to solve this limit problem to solving this one. This one can be rewritten like so because fractions multiply by going this times this, this times this. So now it's easy for my brain to understand that this is just going to be 1. Oh, so if I plug in a really big number up here, I'm going to get really close to 4. Does that help, Justin? Cool. Please, Chris.
So if we don't have to worry, or you kind of saying we don't have to worry about the addition of the 10,000 multiples?
Only because the numbers we're dealing with are infinite.
Yeah.
Meaning they're so large you can't even comprehend them. And I said the elephant and the ant.
Okay.
A better example is Einstein is famous for doing thought experiments. I think it really helps. Like literally trying to visualize a scale, like the Brian Regan joke, a scale, and you step on the scale. Never mind. Okay, it's a good one. It's a UPS. That's good. Okay, you have a scale. Picture the Earth sitting on the scale. And imagine the number you would see for the mass of the Earth. Well, if you pick up an ant and place it on top of the Earth, that number is going to be affected, but by such a small amount,
You don't care.
we don't care. So in the limiting sense, it does have an effect.
But if you go over to the next one, would we use kind of the one main factor? Or?
Hold 1 second. Let me copy it and then we'll talk about it. Hold that question, Chris. Let's finish here and then we'll go to that. Perfect. Don't let me forget that. Anybody else? Oh, please.
So the 4 is only I guess only the answer if it's a huge number. So it's hypothetical.
Hypothetical is a good way to think of it. And honestly, so we're just talking about x and y coordinates. So try to visualize, this is the y-axis. We're going way over here, I'm doing this for you. x-coordinate's really big. The y-coordinate we find isn't exactly 4,
But it's near.
very near. Because in doing the computation, this had some effect. That's why this doesn't turn out to be 4, but it's really close. Because just like the weight of the Earth plus the ant is different than just the weight of the Earth, but not by an amount that we care.
So it's just like the estimate, like it will be near 4.
That's why it's a limit. It's a good call.
When you say near 4, does that mean like 3.999 infinitely or like 4.001?
One of the two.
Doesn't matter.
Dawson, one of the two. In this case, it's actually going to be the 3.999. No, wait a minute. Yeah, because it's a little bit bigger, but they don't care. So I don't stress myself about trying to figure that one out. It's a good question, though. Please.
Is there a value that you could times n by, like on that bottom that you're adding it to? Is there, like in the very top, that like you're times n squared plus? Is there a value that you could times n by to make it like?
Oh, over here?
Yeah.
Oh, I got you. Let me say it back to the class. Really good question, Carson. I think what you're saying is, what if instead of 10,000, everybody's going to earn points on this. I want you to participate, so I'm going to ask a question in a second. This says 10,000 times n, right?
Yeah.
What if instead of 10,000, it said 10 trillion? Fair? Is that kind of what you're thinking?
Yeah.
Awesome. They're still being added. The value of n is still allowed to grow forever. So I want you to vote. If this says 10 trillion n, if it now is important and we can't just disregard it, you're going to go like this. If you're like, oh no, we can still disregard it, this. Show me your answer. So if this is 10 trillion n, we can't disregard. Yeah, you got it. Give yourself 3. Good work. Yeah, the key point is this, Carson. Whatever number you pick, this is going to be allowed to grow so much bigger. Because infinite. Does that answer your question?
Yeah.
Good call. It's why they wrote the question this way, Carson. For years on the AP test, they had given questions that looked like this. Right? So they are constantly trying to outsmart you. To say, hey, let's see if the students really understood what we meant by comparing them. Or they just tried to copy their teacher. So instead of having one that looks like this, they make it look like this. And some students who didn't take the time to really understand it are completely fooled. They're like, wow, it's different now. What do I do? So good question. Please, Calvin.
So isn't 10,000 also going to be infinite? Or why is it?
Smart answer. Okay. It is also big. It really is. But by comparison, this one is so much bigger, it still is negligible. It's hard to visualize that until you take out a calculator and make a table. Put n squared in one column, 10,000 n in the other, and then start plugging in bigger and bigger values of n. And eventually you see that the 1 is just so much bigger. So that part you're just kind of trusting me, but that's a really good observation. Anybody else? Sorry, getting a little excited up here. Okay. In the homework, you are asked to find the limit, but then because in prior years I have seen students really struggle with what is meant by a horizontal asymptote, in each homework problem I ask you to do an extra step. I ask you to find the horizontal asymptote. Okay, horizontal asymptote is really easy. It just is asking you to figure out, hey, when the x-coordinate's really big in either direction, what does the y-coordinate seem to be becoming? You found it. When the x-coordinate's really big, the y value is really close to 4. So just write it down. Right, it's not equaling 4. For an asymptote, it actually can equal, it's still legal. But in this case, it's getting close. So you just write on your homework, horizontal asymptote, y equal 4.
So is it two separate answers, or is it you were trying to find the horizontal asymptote and you're just rewriting it?
What I'm trying to get you to do, good question, Justin, is on the AP test, sometimes they give you questions where they don't talk about a limit as x approaches infinity. They talk about horizontal asymptotes. You need to be able to remember that they're the same. So So that's why I'm asking it here.
Alright, so the limit's 4, but also the horizontal.
Also, the horizontal asymptote, also 4.
So it's like two different answers, but they're the same. Okay.
Perfect. They have exactly the same meaning. They're found exactly the same way. They just test you both ways. So, another thing you're going to have to do here, though, is we got to check the negative infinity because we didn't check that. So you're going to do this. Let's see. X is approaching negative infinity. Okay, the good news is that the comparison is still valid. This would become a very large positive number. This would become a very large negative number. But adding them together, this will completely dominate. So we're still here. So 4 is still the answer. So I've double checked it just to make sure. There are a few cases in the homework where there are different horizontal asymptotes. So you do need to check it. Question. So what I did is I said, well, it really should be n. If n is approaching negative infinity, I come back to the original problem and notice, I don't do anything with that. I can still compare these because they're adding. That's this idea. Well, this would become very negative. This would be very positive. The positive and negative isn't important. What's important is this is so much larger than this.
So they're like well, if it's all both the same.
If they're both the same, you just add them together. Yeah.
Cube.
And cubed still would go faster. Yeah. But yeah. Perfect. If you look at the packet, look at the very back where Carrie is. The answer. Okay, look. What you're searching for on these problems is 1 to find the correct limit. For example, problem number 1, the answer to the limit is -1. Then you're asked to find the horizontal asymptotes. So I listed there's a horizontal asymptote at y equal -1. The rest of this you don't necessarily have to write. I'm just trying to make sure you understand how I figured out that there was a horizontal asymptote. So I'm giving you some additional information in each answer to help you. So don't feel confused by that. Questions about how the answers are laid out. Again, do not use the answer to work the problem. Make sure you are understanding the problem and you're using the answer to give you positive feedback, like verifications. Okay, back to here. Questions here about any of them? Cool. Let's go here. Suddenly the board is very large. That's better. Okay, we wanted to do this one, right? Somebody asked? Yeah. So let's copy this over. Hold on a second. There we go. Move this off. Move this. Okay, so put this in your notes as well. Okay. You have a limit. N is approaching infinity, so we do the same thing again. We compare. We look for things that are being added. Points for the whole room. As long as you're willing to participate, you get the points. So raise your hand if you can tell me what are 2 things or 3 things that are being added in this situation. There's more than one right answer. Just name something that's being added so we can compare them. As long as your hand is raised, you get the points. Let's go, Elena. So the 1's being added to what? So make sure you include the negative because we're looking at things that are adding. So absolutely, we've got negative 2n squared being added to 1. So 2 points if you had your hand up. Everybody see that okay? So we just compare them. If n is going to get bigger and bigger and bigger, raise your hand and tell me which of these 2 will dominate. Show me that. If n gets bigger and bigger, which of the 2 dominate? Aisley. Don't forget the negative, but you're fine. The negative 2n squared dominates. Give yourself a point if your hand was raised. So the negative 2n squared dominates. Then we compare these 2. Which one dominates? N cubed. Which one dominates in the numerator? 3n squared, 3n cubed. So you get a new limit problem. Looks like this. Just comparing the 2 things that are adding and just asking yourself which of these 2 will dominate. Question. Please.
Wait.
Go ahead.
If it's negative 2n squared.
Shoot. Oh no, go ahead and say it again. My bad.
So if it's because once if you have a really big number for n, wouldn't it just be negative once it's multiplied by the 2?
This would be extremely negative.
Oh, okay.
This would be extremely positive.
Yeah.
The positive and negative isn't important.
Oh.
What's important is this will be so much more positive than this is negative that this becomes negligible.
But if it's that and the 1, wouldn't the 1?
Oh, if you're comparing these 2, then this is negligible. But if you're looking at all 3 simultaneously, you've got 3 things on the scale. Okay?
Yeah.
This one is so much more negative than the other 2, you don't even notice. Like it's very negligible.
So are we trying to find the biggest numbers on the top and the bottom?
They are analyzing definitely the well, honestly, what we're looking for, what's being added. Because if things are being added, it's easy to compare them.
Yeah, because we said we were comparing the 1 and the 2n squared, but then we compared the n cubed to the negative 2n squared, but we only wrote down n cubed.
Gotcha. Because what we really did is we compared all 3. We said we've got 3 things being added. This one, so much more significant than the other 2. I don't really notice that I'm even adding them as n gets extremely large.
So basically it's just kind of like you're trying to find the bigger one.
Trying to find the dominant term among the terms that are being added. Perfect, Tori, please.
So it's kind of like comparing the earth to an elephant to an ant.
Perfect, perfect, perfect. And it's even weirder than that, really, because like Calvin said, they all get unbelievably big. Just the one is so much bigger than the other. Think of it this way, Tori. If we could use, like, the world's, I don't know, if we could somehow write it all out, it's like this value, n cubed, would be like negative 1 and then 100 zeros or something, right? This would be like just this much of the number. It just isn't significant enough. So, anybody else? Cool. So now you factor and divide. So I think of it this way. Now I know the limit is 3. And because n was approaching infinity, I know there's a horizontal asymptote at y = 3. I need to check what's happening as n approaches negative infinity.
down as approaches infinity, or do we need to check in our head?
I'm good either way on this one. I hate to have homework that has, I don't want any busy work, but just make sure you're really cautious about it. Honestly, if it were me, this isn't a whole lot to write. I'd probably just write it. Because what it does for me is, look over here. The biggest risk of having the answers in the back, did I tell you the story last time? So I had a student one time. We're in class, we're discussing some homework problems. The student says, I solved the problem correctly, but I did it differently. And my response was, not a problem at all. Like, if you can find a way to do it differently that's legal, it's fine. So I need you to tell me what you did, because I've got to check your logic. If your logic is incorrect, you're never going to get another problem right ever again. Okay? So I said, tell me your logic. The student says, I first did this. And I paused because I'm like, I was trying to find a nice, polite way to say, you are completely wrong. Okay? Like, you can't do that, it's illegal. So I just didn't know what else to say. I'm like, sorry, that's illegal. But then I asked the student, I said, but you said you got the right answer. And the student says, I did. Okay, well, you did the first step completely wrong. What'd you do in the second step to somehow get the right answer? And the student said, I did this. Well, that was also illegal. So now the person has done 2 illegal steps. I'm like, how did you get the right answer? I don't know, I just went for it. What? Like, you did this wrong, you did this wrong. What was the third thing you did? She said, I just went for it. What do you mean went for it? I just got the right answer. Okay. All she's doing is this. She's like just writing something down, writing something else down. And then she looks at the answer and goes, oh yeah, see, that's what you get. Like, there's no logic at all. Okay? None. You can't do that in this class. You cannot just memorize problems. The test doesn't look like this. Okay? This is how we learn the concepts. Then the problems I give you are old AP problems, which are just whatever. Okay? So what I'm saying to Justin is, I would probably write it. Because what I want is I want to confirm that my thinking is correct. So I'm doing all this before I look at any answers. Then when I go to the answer, I just get that nice positive feedback of, oh yeah, my thinking was correct. And if it's wrong, I got to get in here and talk to you. What, how am I thinking of this incorrectly? So, other questions to you? So for negative, I do the exact same thing. I compare things that are adding. But look, with power functions, the sign doesn't really matter. This would be very negative. The negative would make it positive. This would be very negative. But really, really negative added to not very much positive is going to be dominated by very, very negative. Okay? So really, I get the same place. I still just have this. By the same logic, the bottom still looks the same. So this is also 3. So I've just made sure that I don't have a different asymptote, which you normally don't, but sometimes. So the horizontal asymptote is definitely 3. I'm done. Please.
Wait, I'm kind of confused. Can you show what it would kind of look like on the graph? So is it something sort of asymptote like this way, or it's like this way?
Yeah, it doesn't matter the direction as far as we're concerned because we're not going that deep. So what I know is I don't have any idea what's happening here because I didn't analyze it at all. All I know is that when n is really big, so way over here, the y-coordinate's going to be close to 3. So I don't know what it looks like. I just know, well, the y-coordinate's somewhere in the vicinity of 3 when I'm over here. So maybe it does this. It helps if you draw the line. Maybe it does this. Maybe it does this. Come on. It might even do this. Any of those are valid. We don't really know. We didn't analyze it. And then on this the negative side, something similar is happening. Is that what you meant?
Yeah.
Like, we don't really know. We just know that it gets close to 3 somehow. Lots of different ways it could do that.
Okay.
Does that answer your question?
Yeah, so I guess it would never be negative.
No. When the n value is very negative, the y value is still positive 3.
Okay.
Because, again, I'm just comparing. When n gets very negative, this will become very positive. This will become very negative. That big, big negative dominates. So I just ignore that and write down the 3n cubed. On the bottom, this very big negative also dominates. Well, now you're going to have like big negative divided by big negative. That's why it switches back to positive. So.
Yeah. So if y were negative, would it be like negative 3n cubed over n cubed, and then it would be negative?
Then it would be negative.
Okay.
Yeah. If this constant, Sarah saw that really nice. If this constant were negative 3, when you make the comparison, the negative 3 would still, this would dominate. But that would have caused this value to be also negative 3. So you'd have a negative 3 in both directions. Good question. Please.
How do we do, like, figure out how it's going the other direction is a different number before
Cool.
we get to that?
It doesn't happen very often, but let me show you an example where it did happen on the homework. Since your question is so good, Justin. Turn to number 5 in the homework. Feel free to write this down as long as it makes sense to you. So x is approaching infinity, so I have to compare things that are adding. Well, in the numerator, you've got a power function being added to this exponential. This is very much like Tori's example again. This is like the Earth, except it's like an Earth that grows. I don't know. This is like the elephant. It also grows. It just doesn't grow as fast as the Earth. So when you're adding them, you can ignore this one. So we get to here. On the bottom, very similar. So stop right here. We'll call that step 1. Anyone have a question about step 1? Step 2, factor and divide. This becomes 1. I know that when x is really, really big, the y value is going to get very close to 4 again. So I found the value of the limit, which means I have found a horizontal asymptote. So horizontal asymptote is the same thing as finding the limit as x approaches infinity. Question? Please.
How do you know if there's not a horizontal asymptote?
So if this is the graph, and here's the y-axis, if as x gets really big, the y value either gets really big as well, or the y value gets very negative, or I have seen an AP problem where the y value just does this. None of those would be a horizontal asymptote. Did that answer your question?
Yeah, so how would we find that out?
Oh,
Find
what?
that?
Gotcha. Keep watching. If this doesn't answer it, we'll keep talking.
Okay.
But I think it will in a second. Good job, Elena. Other questions to hear? So what I was saying to Elena is that as x gets really, really positive, we have discovered that the y value will get very close to 4. So that is a horizontal asymptote over here. Now we need to check what happens as x gets very, very negative. So that's what I'm writing here in green. Okay, the comparison changes dramatically now. You put in your notes that e to a negative number that gets bigger and more negative, it's really close to 0. This would become extremely negative.
Oh,
So,
yeah, I put that up earlier.
yes,
Okay, okay.
really big negative added to something close to 0. What dominates? a really big negative, 2x. So if x is approaching negative infinity, I should have put a y here. The y value is approaching this. You know, I want to talk about the green here.
So is the 2x over 4 the answer?
No, now you've got to apply some logic to it. On the bottom, this gets really close to 0. Added to 4, the 4 will dominate. So I get this. Now this is the answer to Elena's question. So as x gets very, very negative, this will get very, very negative. And this will just stay 4. Okay, really negative divided by 4 is going to become very close to negative infinity. No horizontal asymptote in that direction. The graph just keeps going down. So that's what you were kind of asking, right?
Yeah, thank you.
Good question, Elena. Please, Ashley.
How do you know when there's a horizontal asymptote? Because there was one for when x is going to infinity.
Oh, yeah, my
Why
bad,
isn't
sorry.
there one when it's going to negative?
Gotcha. What you're paying attention to when you're thinking horizontal asymptote is, you're just trying to think, okay, I got to figure out what happens when my x-coordinate's really big. Or when my x-coordinate's really negative. You with me? We figured out that when the x was very positive, the formula for finding the y-coordinate is pretty much this right here. Are you comfortable with that?
Yeah.
Awesome. That means when x is really big, the y-coordinate's going to be really close to 4. That means that's a horizontal asymptote. That's what horizontal asymptote means. If the x-coordinate's really big and the y-coordinate's getting close to something, some fixed value, horizontal asymptote. In the other direction, when x is very negative, we figured out that the formula looks like this. Well, if this gets bigger and bigger and this stays at 4, the y-coordinate is going to go very negative, not a horizontal asymptote. I'm not sure I answered your question, though.
No, I think I know.
Okay.
Because it just keeps going from infinity, so it
Right.
never
Perfect. Yeah, think of it, see if this helps. Like if I can picture the graph and I see when I go this direction, if the graph's going to do this, no horizontal asymptote. If I see the graph going like this, no horizontal asymptote. If the graph is settling out to something like 4, that's a horizontal asymptote. Good question, Ashley. Justin.
So basically, if it has an E in it, it'll probably have a different thing.
Everyone listen, everybody listen. 3 points to Justin for asking a good question, but here's my caution. Don't memorize little shortcuts like that. They will fool you. Like they'll find a way to just make that not work. You are correct. When I saw this problem, I saw the E and I thought, oh, wait a minute. If I go to negative infinity, I gotta be cautious. But I don't just make the conclusion that that's it, because it's not true. It depends on other factors as well. So yeah, don't memorize that. Good questions. Please.
So if you're looking at the graph, like from 0 on, would have the horizontal asymptote at 4?
Really? It's kind of related to what Sydney said. Hold on. Not exactly. Okay, when we draw a horizontal asymptote, you'll see teachers all the time do this. Okay? That's not the horizontal asymptote.
It's just wherever it starts.
That's just so I can kind of visually see what's going on. Horizontal asymptote just means that at some point, way over here, the y-coordinates are going to get close to 4. They may even equal 4, but they'll get closer and closer to 4.
Does it have to end that way? Or can it just like be there for like?
Oh, awesome
10
question,
minutes and then
Sydney.
move on?
Awesome question. It has to stay that way. That's why it's all about x approaching infinity.
Like the end results.
Yep. It's last year they called it end behavior. It's the same thing. They just couldn't use the word limit because you hadn't talked about limits.
Yeah.
But it's the same thing. So it doesn't, like I said to Josh, you don't know what's going on here. It just doesn't matter. We don't care. Anybody else here?
But that's why you need to write for like the notation just says like for that horizontal.
I would write exactly what you see here. I'd flip to the back. So after I have that written down, I would flip to the back and just verify that I'm thinking correctly. Because I'm using the homework like a test. I want to see, hey, if this were a test question, would I have gotten it right? I want that positive feedback. So number 5, there's a typo, great. Should say y equal negative infinity. So 4 is the value of the limit that they asked me to find. That tells me I know there's a horizontal asymptote of y equal 4. Now I'm going to check at negative infinity. As x approaches negative infinity, the y value is approaching negative infinity. So there was no horizontal asymptote in that direction. And then here I'm just clarifying that as x approaches positive infinity, y does approach 4. Sorry, I gotta grab the water bottle real quick. Being a teacher, it's like being a panther in the zoo. I'm serious. It's like, what's wrong? Oh, he's drinking now. Now he's hiding in the corner. The poor animals right there. You people, please leave. I once helping students after school. I had to get something from my car. I think it was in a different, I don't know. Somehow they saw me outside the window, like, oh look, he's outside the window now. He got out, he's in the wild. This is his natural habitat. I once, I kind of pushed, I haven't been able to do this lately, it just hasn't worked out. I had several years where I would kind of in a coded fashion let students know that if they drop by my home on Halloween, I would be sure to give them something nice for trick-or-treating. And so one time some students dropped by, and they look in the house and they come in, because I actually come in and sit at my kitchen table and made them something nice. And it's a big party. And they're like, this is where he eats. Please, Justin.
Alright, so it's like, you know how I said don't make the shortcut, so it's like a D is always going to be different. When would it be like a case where that's not it? Where it's like, if you have it, like, it has the same.
Oh, ever so clever. Justin should be an AP test writer. I just have to dream one up. I don't have it memorized. Here's one that we can do. So look at this. He said, why do I not want to just use the trick that E is going to make it different? So the test writer says, oh, I'll write a special problem for Justin here. Make sure he doesn't get this one right. Sorry, no offense. Hold on. So we were here, right? No. We were here. No, come on. Too many problems on this board. We did that one, right? And then we did number 5. So here's what I was saying to Justin. They give you this problem. Do that one. This is very much like the homework. I would write this down. This is a good one for your homework notes. This is a good example. Justin asked the question, but it's a very good example to have in your notes. Okay. X is approaching infinity. So I want to compare things that are adding. Nothing's adding. I want a factor. Can factor. So you're left with just using logic. As x gets big, what happens to the top? It's really, really big. Bottom gets big too, but which gets bigger faster, top or bottom? Top. If the top goes much faster than the bottom, the y-coordinate is just growing. So the value of this limit is infinite. So no horizontal asymptote, like I was saying to Ashley, because the y value just keeps creeping up. So no horizontal asymptote. Questions to there? Justin's comment. We got to check what's going in the other direction. So we say, okay, well, what happens when x approaches negative infinity? Well, because this is squared, the negative has no effect. It's still e to a very big, big number, bigger and bigger. So top just keeps growing. Because this is squared, the bottom didn't change either. It just grows as well, but the top grows so much faster than the bottom, it's still headed towards infinity. So there was no difference in either direction.
Because it was squared.
Because it's squared. And there are lots of other ways to do that as well. That's why I say, okay, I'm giving you a set of logical ideas that I have found never fails. Like I check the limit, it's going to infinity, I compare things that are adding. Always works. All of the tricks, I just don't memorize them because I'm just worried they're not going to work. Please, Lynn.
Can you just explain how you did the negative and
So as x gets bigger and bigger negatively, that means I'm plugging in something here that's really, really negative, and I'm squaring it. Once I square it, it's positive. So it behaves the same way as if I plugged in something that were positive and big. So the top's just going to get big.
Okay, and it wouldn't approach 0.
It's not negative, it's just big and positive. The bottom is also big and positive. But the top is so much bigger than the bottom, it grows.
So it's not like it's 0 for like the exponential.
The exponential approaches 0 if it's e to a negative number. Then it approaches 0. Because the exponent is squared, it just gets bigger.
But if it were like odd,
Then it would approach 0.
Basically, it's like an odd exponent. The things can be different for the most part.
Most part is the key word. Like I hate to say, oh yeah, that's it. It's like, okay, now let's do this one that's different. So you just have to keep that element out. You don't have to reason it out. Okay, write this one down, please. Oh, sorry.
What does it mean? Like, what's
Oh, e is just a number. Like, just to help you understand it, what's pi? 3.14. E is about 2.7. It's just a constant that showed up in nature, right? Like pi. So they got tired of writing 2.7, so they write e.
So it would just be like 2.7 times.
There's 2.7 to a power. It's going to behave, Sydney, honestly, a lot like 3 to a power.
Oh.
It's close to 3.
Yeah.
So if that helps, just think of it, oh, I just got 3 to a power. So
Yeah.
write this one down. You'll need this for your note. I heard a joke once that is very applicable. Most everyone agrees. The person said, hey, I was good at math till they threw in the alphabet. Look, don't let A bother you. A is, on the AP test, in this type of situation, A is a constant, meaning it's 5 or 6. You don't know what it is, but it's not, you don't treat it the same as you treat X. Okay, it's a constant. Are you with me? Okay, so X is approaching 5. So we cannot compare things that are adding because X isn't approaching infinity. See why I'm skipping that step? Go to the next step, factor and divide. Okay, I see a difference of squares, both top and bottom. So I want to factor. But I can kind of see that this on the bottom is going to factor and look like the top. Memorize. the whole reason you're factoring is to get matching factors. Otherwise, factoring doesn't help. Like, we want to factor to get matching factors. So the next line in your notes should say this. So I left the top alone because I realized that when I factor the bottom, one of the factors of the bottom is going to look like the top, which is what I was wanting. So that's factored in a way that's helpful. Question?
Is the homework going to be easy?
The factoring in the homework mimics the AP test, meaning, again, after studying so many years of AP tests, I've concluded that 99% of the time, I cannot go to the 1%, I don't know what they're going to do, but 99% of the time, they don't give something that's hard to factor. So, we good here? Okay, I factored because I want to divide. So I look at it like this now. Question? Okay. If x is exactly a, this will become 0 divided by 0. I don't know what that is. But I don't care. I'm finding a limit. So I don't care about what happens when x is a. I care about what happens when x is almost a. So this is 1. Like if x is exactly a, this is, I don't know. Otherwise, this is 1. 1 times this, just this. That's why I factored. So now I have this one. Questions? Okay, now I do the last step as I just think about left and right. Well, it's a little hard to think of plugging in something close to a, so we're going to cheat a little. We plug in exactly a. This would be a squared. That would be added to another a squared. You now have 2a squared. A squared plus a squared, 2a squared. So if this were close to a, yeah, the bottom would be close to 2a squared. So the value of the limit is 1 all over 2a squared. Okay, this time we did not find a horizontal asymptote because the limit is not x approaching infinity.
So instead of having actually made the x that a, because there was x.
Right, because I want to know what's happening when the x value is close to a.
So then you made it a, and then you added it in as to a.
Perfect. Question? A squared plus a squared. Please,
I'm
Chris.
still confused why it's 2a squared. Why I would
No worries. What's a plus a?
2a.
Good. Same logic. If you have an a squared added to another a squared, you have 2a squared. Keep talking.
Okay, why do we just, how can we just turn the x to an a?
Oh, it's all about what limit means.
Yeah.
Limit is telling you this. Here's your formula to find every y coordinate of a function.
Yeah.
I want to know what's the y coordinate when the x coordinate is nearly a.
Okay. Oh, I see.
When the x coordinate is exactly a, the y coordinate is unknown. But when the x coordinate is very, very close to becoming a, this is the y coordinate.
Okay.
There we go. Please.
And there's not a horizontal asymptote?
We don't know. Because all we've checked so far is what's happening near a. So near a, we know this is the y coordinate. To finish the homework problem, we'd have to go find the horizontal asymptote now. So we want to see what's happening when x gets close to infinity. So now I do a different problem. Now I say, okay, if x is approaching infinity, I can compare things that add. Well, on the top, just say it out loud. What's going to dominate? Say it. X squared. So as x approaches infinity, well, let's make a shortcut here. It wouldn't matter whether it was positive or negative infinity. In either case, the y value is going to approach x squared on the top, because the a squared doesn't grow. It just stays a squared. It doesn't change. The bottom is going to be dominated by x to the 4th. Questions? Outstanding questions today. Like, really, you guys are just on track. Just keep probing for the meaning. So pretty good? Okay, this can be divided to look like this. Whoa. Okay, now notice, if x gets bigger, that should be an arrow, sorry. If x gets bigger and bigger and bigger, you're going to have 1 over bigger and bigger and bigger. It won't matter if it's positive or negative because it's squared. 1 over really, really big gets close to what value? 0. The horizontal asymptote is at 0. That finishes the problem.
So basically like repeating the problem, but just comparing.
What I'm trying to get you to do is understand that we can find a limit at any x coordinate, and it tells us a y coordinate, okay? But we can also find a limit as x approaches infinity or negative infinity, and that gives us a horizontal asymptote. Possible. Okay. Good question.
We do like the ones without like fractions like over here.
Like this?
Yeah.
Nothing in the homework like that, so don't worry about it for yourself. Please.
So why would the horizontal asymptote be 0?
So are you okay to hear, Sarah? Hold on. Are you okay that when x is approaching positive or negative infinity, that's what we do to find a horizontal asymptote?
Yeah.
Good there? Are you okay that when x is doing this, we can compare things that add? So we can say this formula can be simplified to this.
Yeah.
Good. Are you okay that by division, this can simplify to this? Okay. So now the top stays 1. The bottom gets really big. So you end up with a pattern like this.
Oh, it just
It's closer and closer to 0.
1 million is pretty much.
Yes, 1 million is much closer to 0 than 1/10. Does that make sense? Good job, you guys.
I mean, like 10,000 years.